Most coverage of Artemis II stopped at splashdown. The part NASA is actually worried about starts now, with 3 systems that still need to prove themselves and 2 landers that have never been tested on a live crewed mission. Miss any one of them before mid to late 2027, and the first moon landing since 1972 doesn't slip by months, it slips by years. Artemis II landed on April 10, 2026, and the world celebrated. What most people missed is that the real gauntlet starts now. 2 more missions, 2 competing landers, a heat shield that needs a redesign, and a countdown clock to the first moon landing since 1972. Every step between here and Artemis IV has a hard technical price, and any one of them can slip the date. This is the full roadmap, with the numbers NASA is actually working to. On April 1, 2026, NASA's Space Launch System left Kennedy Space Center with 8.8 million pounds of thrust and 4 astronauts on board. Commander Reed Wiseman, pilot Victor Glover, mission specialists Christina Koch, and Canadian Space Agency astronaut Jeremy Hansen. 9 days later, they had flown 695,081 miles, looped behind the far side of the moon, and broken Apollo 13's 54-year-old record for the farthest distance ever traveled from Earth, reaching roughly 406,771 kilometers out. Splashdown came at 8:07 p.m. Eastern on April 10th, off the coast of San Diego. The mission worked, but this was a test flight, not a landing, and mission managers walked out of the post-splashdown press conference with a list of things that have to be fixed before anyone tries to go further. That list is what the next 18 months are actually about. Post-splashdown, US Navy divers captured underwater imagery of Orion's heat shield, and what they found confirmed what engineers had suspected. The heat shield had known design flaws going into the mission. It survived, but the data it returned demands a redesign before Orion carries a crew to lunar orbit and back, because the return from the moon is faster and hotter than the loop Artemis II flew. Beyond the heat shield, the Orion service module needs a valve redesign, and a urine vent line failed mid-mission, triggering its own root cause investigation. 3 separate hardware problems, 3 separate engineering teams, 1 target, have corrective action initiated before Artemis III rolls to the pad. NASA has publicly stated teams are working to identify root causes now. The margin for error in space is 0, which means the margin for slipping the schedule is real and present, and the clock is already running. Here is the plot twist most people do not know. Artemis III is not going to the moon. In February 2026, NASA Administrator Jared Isaacman officially redesigned the mission. Instead of a lunar landing, Artemis III will launch 4 astronauts on Orion into low Earth orbit and attempt to rendezvous and dock with 2 commercial lunar landers simultaneously, SpaceX's Starship HLS and Blue Origin's Blue Moon spacecraft. Think of it as Apollo 9, the 1969 dress rehearsal that tested the lunar module in Earth orbit before Apollo 11 flew to the surface. The reason is safety. The Aerospace Safety Advisory Panel recommended that landers designed to touch down on the moon should not attempt their very first crewed flight on the lunar surface itself. Rendezvous, docking, and suit interface tests all have to pass first. NASA is targeting mid to late 2027 for Artemis III, and hardware is already stacking in Kennedy's Vehicle Assembly Building. This is where it gets genuinely strange. NASA has not picked 1 moon lander. It has contracted 2 from 2 different companies, and Artemis III is supposed to test both. SpaceX's Starship HLS is a modified version of the same upper stage vehicle SpaceX is developing for Mars. It is roughly 50 meters tall and requires refueling in orbit before it can descend to the surface. Blue Origin's Blue Moon is a more conventional descent vehicle purpose-built for the lunar program. Both have been in development for years, both are still in progress, and neither has yet completed a fully crewed demonstration. The logic NASA is betting on is that testing both in Earth orbit during Artemis III gives enough confidence to commit one of them to the actual lunar surface landing on Artemis IV. But if either lander slips its own test schedule, the entire chain shifts. 2 landers racing the same clock is either insurance or a complication, and right now it is probably both. Artemis IV is the mission the entire program has been building toward. NASA's official target is early 2028, and for the first time since December 1972, it puts 2 human beings on the surface of the Moon. This is not a repeat of Apollo. Artemis IV will land near the lunar South Pole, a region no astronaut has ever visited and no Apollo mission came within 1,000 kilometers of. The reason is water ice. The permanently shadowed craters at the South Pole are believed to hold significant deposits, and that ice is the most important resource in deep space exploration. It can be split into hydrogen and oxygen for rocket fuel. It can sustain life. NASA describes the South Pole as the gateway to everything that comes after, including a permanent moon base and eventually Mars. 2 crew members will descend, spend approximately 1 week on the surface, then ascend back to Orion waiting in lunar orbit for the return to Earth. The choice of the lunar South Pole is not symbolic. It is strategic in a way that reshapes every mission that follows. Permanently shadowed craters near the pole receive no direct sunlight, which means temperatures can drop below -173 degrees Celsius, cold enough to preserve water ice for billions of years. Scientists confirmed the presence of surface water ice there using data from the Lunar Reconnaissance Orbiter, and the volumes are significant. If that ice can be extracted and electrolyzed, it produces liquid hydrogen and liquid oxygen, the same propellant combination that powered the Space Shuttle main engines and the Artemis SLS upper stage. A moon base that can manufacture its own rocket fuel does not have to import every kilogram from Earth, and the cost arithmetic of deep space exploration changes completely. Artemis IV's 7 days on the surface are the opening move in that calculation. What the crew collects and confirms there sets the terms for every mission after. Here is the chain as it stands today. Artemis II proved the rocket and the capsule can carry people around the moon and bring them home. The heat shield, valve and vent line issues are now in active engineering. Artemis III, targeting late 2027, will prove in Earth orbit that Orion can rendezvous and dock with a lunar lander, and that astronauts can operate in the new Axiom Axamu spacesuits designed for the lunar surface. Then and only then does NASA commit to Artemis IV, the first landing, targeting early 2028. Every link depends on the one before it. A slip in the heat shield redesign slides Artemis III. A slip in lander testing slides Artemis IV. The program has slipped before, repeatedly, and the honest reading of the current schedule is that it is tight. But the hardware is real, it is stacking, and for the first time since 1972, the question is not whether humans will return to the moon. The question is exactly which month. The last piece of this puzzle nobody talks about is what happens if one lander passes its Artemis III docking test and the other does not. NASA then has to pick a winner, under deadline, with a moon landing on the line. If you want the follow-up on how that lander decision gets made, it is next on the channel. Subscribe so you do not miss it when it drops.